Alright, now we're going to bring all the skills that we learned today and make a pretty cool little application. It's called a distance calculator. So what we're going to do is this calculator is going to solve a real basic problem dealing with physics. So there's a problem statement right there. We have a distance d which an object's going to fall under the influence of gravity, and it's proportional to the square of the time t of fall. So here's our parameters. If the object falls at 64 feet in 2 seconds, we want to know how far does it fall in 6 seconds. Oops. Let me find my little cursor here. I'm using a wireless mouse, so excuse me if it kind of delays here. That's technology for you. Okay. Now, we have requirements. Whenever you write software, you always want to attain requirements, which is basically what the customer wants. In this case, we need to know what is it we're trying to do and how we're going to set up the solution. So we have a solutions requirements paragraph that I created, and what we're going to do is we're going to generate a list of distances. That's the solution, and we're going to use what's called an array, and we're going to use an counter. Now, I mentioned before about when you have a counter, there's vast amounts of data that you want to read into a variable, and then you use a counter that's going to allow you to read the data out, or I should say write the data out. So we have a read-write function within the counters, and the way we can contain that information is using an array. And an array is just basically a software variable or a container that stores vast amounts of data. So in this problem, we're going to use an array, and the variable that we're going to use is k, and you'll see that in a minute because it's based off the equation that I obtained from my physics book. So we have this variable k, and then we're going to read in the list of data. So you can see the data that we're going to read into this variable, or in this case the array k, and you can see it's 2, 4, 6, 8, 10, 12, and 16. And then we have a counter, and again that counter is going to allow us to read the data in each one of those variables, or I should say into the array. So the way the array works with the counter is the first position will be at k0. So the value that will be associated with k0 will be 2. At k1 it would be 4. At k2 it would be 6. At k3 it would be at k4 it will be 8, and etc. Okay, so we're going to read this data into each one of those little variable positions using a counter, and it really makes the whole process of managing vast amount of data very, very easy. So here's our equation. It's d is equal to k times t, and we're going to square the t. So right here we have the equation, and this is known as kinematic equations. In physics they have the Newton's law of motion, and they decided to call it the kinematic equations that relate to motion related to acceleration and velocity. So this one is dealing with the distance, and that's part of the kinematic equations. So there's the variables and what they mean. D is the distance in feet, k is the acceleration in feet per second square, and t is the time in seconds. And I got some notes here. And in math or in programming, we use that little, I call it the little caret symbol, and that's how we square items in math when we do programming. But we're going to see something a little different here, and I'll explain what that difference is, how we can show squares within the Python scripting language. We have k, and again in the problem it states that in this case for this problem it's going to be 16 feet per second square, and of course our time that we want to know when this object is falling is based off of 6 seconds. So we have our equation, we make the substitutions into the equation, so you can see right there that is how we're making our substitutions. We take 16 feet and we're going to plug that into the equation, and then we're going to multiply the 6 seconds, and we're going to square that. And once we plug those numbers in, we get our answer, which is 576 feet. So we're going to set that up in Python. We're going to generate this little list of data related to distances, and we should see the answer 576 feet being one of those answers. Okay?